Number 25. You can determine the index of refraction of a substance by determining its critical angle. Letter A. What is the index of refraction of a substance that has a critical angle of 68.4 when submerged in water? What is then this substance? All right. So if you're thoroughly confused on the wording of this and how to think through it, so am I. So I guess we're in the same boat. I think what they're trying to get at here for letter A is let's use our critical angle formula. I would highly suggest you review number 20 where I developed this. This is going to be N2 over N1. All right. Now N2 then must be less than N1. I'm just repeating basically what I said in that video. So what you will realize when you take a look at that, all right, is that the critical angle here is associated with N1. Okay. In other words, this critical angle, sounds like, ooh, something special, but it's basically the incident angle, okay, upon which there is a 90-degree refracted ray. Okay, take a look at number 20. So if this is the incident angle technically, and this is the index of refraction of the incident ray, okay? Because this is really theta sub 1, and I've been using that terminology now throughout the videos. So what I realize here is that they're giving me the critical angle, and I'm going to plug that in for then theta sub c. So this is 68.4. That's equal to then the inverse sine of now N2, okay? Well, what is N2? N2 does not correlate with the critical angle, essentially. Essentially, what I'm trying to say is that the water in the problem is N2. In other words, the index of refraction for water is my N2 value. This is the refracted thing. The light ray is incident. It is incident inside this unknown material, and then the light is then going to be totally internally reflected. In other words, the refracted ray in water must be at a minimum 90 degrees. So that's now why I'm going to plug in 1.33 here. Okay, and then divide that then by N1. Now what I'm solving for is N1. Okay, so in order to do that, you must take the sine now of both sides because you have to cancel the inverse sine. All right, so that'll cancel that. What you're now left with is going to be sine of 68.4. Plug it into your calculator. So this is going to be 0.9298, I guess, is equal to then 1.333 over N1. Simply cross multiply. And now you're going to get your N1 value, and this is now 1.333. And this now is the index of refraction. Okay, this is 1.43 or so, right? 1.43, I guess, ish. So this is now the index of refraction for that unknown material. All right. So let's look this number up on our table, 1.43. So we go to our table and we're going to look up 1.43. Oh, look, right? If you look at the rounding, this is pretty much it, right? Fluorite. Okay, so the material here is fluorite. There you go. All right, so letter B. What would the critical angle be for this substance in air now? All right, so they're asking us to do now another calculation there. They're asking us this time for the critical angle. So remember that's equal to the inverse sine of my N2 value over N1. Remember N2 has to be less than N1. So you're talking about air and you're talking about fluorite. Air has an index of refraction here of about 1, right? It's like 1.000293 or something. You could just use 1. So that's the lowest value that has to go on the top. All right, so this is 1. I'm just going to use 1. And then that's going to be divided by 1.43, blah, blah, blah. All right, when I do the calculation, I'm going to use the exact value there. So it's going to be inverse sine of 1 divided by then that exact value from before. And we get about 44.2 degrees. All right, 44.2 degrees. That is now the critical angle. All right. So notice, if the index of refraction here gets lower, right, from water, let's say, what happened to the critical angle? The critical angle also gets lower, right? Compare them. Thank you very much for tuning in. All right. I hope this helps. And I realized I wrote A over here, but that should be a B. Okay, a B. I will see you in the next one. Take care.